Thank you for listening. This course was created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional podcasts, books, newsletters, and cool merchandise await. Let's get started. Guardrails are technical controls that constrain what models may say or do, applied during or after inference to enforce safety and compliance boundaries. Think of them as fences around a playground. The model can run and experiment inside a safe area, but it cannot wander into zones where it would cause harm, leak secrets, or violate policy. Guardrails do not replace input validation. They complement it by catching misbehavior that slips past sanitization or that emerges from complex reasoning across knowledge and retrieval. In practice, a guardrail is a layered artifact, a set of code, tests, classifiers, and policy rules that sits in the inference pipeline and checks outputs against organizational expectations before those outputs are consumed by other systems or presented to users. For you as an operator, that means choosing guardrails that reflect real-world harms, measuring how often they fire, and treating them as living safety features that evolve with usage and threat intelligence. The purpose of guardrails is pragmatic and strategic. Prevent harmful content generation, enforce organizational policy, reduce operational risk, and improve overall trustworthiness of deployed models. Preventing harm ranges from blocking illegal instructions to avoiding the inadvertent release of private data. Enforcing policy means ensuring outputs align with contract terms, regulatory requirements, and brand voice. Reducing operational risk focuses on preventing cascades automated actions triggered by a model that should have required human sign-off. Guardrails thus transform abstract policies into actionable, testable rules. They answer the questions users and auditors ask: what was prevented, why it was blocked, and how to proceed. When implemented thoughtfully, guardrails also make product teams bolder, because you can ship more capable interactions with a clear safety net that contains worst-case outcomes and logs the evidence needed for review. Guardrail types span syntactic output filters, semantic consistency checks, policy enforcement layers, and structural formatting validators, each addressing a different axis of risk. Syntactic filters operate on the shape of text or data, length limits, allowable tokens, and schema conformance that prevent malformed outputs from breaking downstream processors. Semantic consistency checks evaluate whether an answer aligns with source evidence or established facts, catching hallucination and unsupported claims. Policy enforcement layers codify business rules, such as contractual prohibitions on advising on regulated activities, and act as gatekeepers that reject or redact disallowed content. Structural formatting validators ensure outputs meet expected machine-readable formats, so automated consumers cannot be tricked by cleverly formatted prose. Together, these modalities create a spectrum from lightweight guards to heavyweight policy enforcement, and choosing them requires aligning technical cost with the severity of possible harms. Prompt guardrails are the front line against input-driven attacks and scope creep. They restrict sensitive inputs, detect injection attempts, reject malicious prompts, and scope queries to allowed domains. Restricting inputs means defining what users may supply in free text fields, no upload of private keys, no raw internal logs, and strict rules about embedding system instructions in user content. Injection detection blends pattern recognition, canary prompts, and prompt parsing heuristics to spot attempts to hijack agent behavior or exfiltrate secrets via retrieval augmentation. Rejection is a legitimate outcome. Based on risk scoring, the system may refuse to service a prompt and return a safe error or escalation path. Scoping queries limits what external knowledge the model can incorporate, constraining retrieval to vetted sources and defining fallbacks when no trusted context exists. For teams, prompt guardrails are a balance between expressivity and safety. They shape user behavior by making acceptable interactions clearer and risky ones harder to execute. Output guardrails work after generation to validate, filter, and, if necessary, modify or block model responses. Post-generation validation includes classification of toxicity, detection of legal or privacy violations, removal or redaction of unsafe passages, and strict enforcement of response formats for automated consumption. Multi-stage checks are common. A lightweight, low-latency filter drops obvious disallowed tokens. Deeper semantic evaluators run in parallel or asynchronously to flag complex policy breaches for human review. Where actions change state, sending an email, initiating a transfer, or updating a record output, guardrails elevate requirements with step-up authentication or explicit human approval. Human-in-the-loop workflows are essential for borderline cases, and safe fallback responses should preserve user experience while avoiding risky automation. For organizations, monitoring how often outputs are blocked, why, and what remediation improves the balance of safety and utility is the crux of iterating guardrails effectively. Context guardrails focus on the provenance and composition of the information fed into models, screening retrieved documents, limiting context window exposure, preventing hidden instructions embedded in artifacts, and controlling external sources. Screening retrieval means vetting candidate documents by trust score, origin, and freshness before they become part of the model's immediate context. Pre-filtering can exclude user-uploaded files that fail signature, licensing, or privacy checks. Limiting context window exposure entails prioritizing what the model sees, summarize long documents, redact sensitive spans, and treat nearby, user-provided snippets with greater scrutiny than stable, verified knowledge. Hidden instructions are a real vector. Captions, metadata, or overlay text may attempt to carry directives that bypass prompt filters. Guardrails sanitize or ignore these channels unless they pass verification. Controlling external sources, whitelists, provenance checks, and quota limits reduces supply chain confusion and gives you a defensible policy when incidents require forensic explanation. Context guardrails transform retrieval from an open invitation to a curated pipeline with clear accountability. Operational deployment of guardrails requires thinking of safety as a first-class element of the inference pipeline, rather than as an optional add-on. Place lightweight syntactic checks as close to the model as possible so malformed outputs are rejected before downstream processing. But implement deeper semantic validators in parallel paths that can take slightly longer and feed human review queues when needed. Design filter layers to be horizontally scalable and stateless where feasible, so spikes in traffic do not create safety bottlenecks. Use caching and precompiled rule tables for low-latency checks, and offload heavier semantic analysis to scalable workers with graceful fallbacks. Modular guardrail services let teams compose policies, prompt filters, provenance checks, and action gates without hard-coding rules into models, enabling policy iteration without model retraining. Operational deployment also requires clear observability. Each enforcement action should emit structured records with context, confidence, and rationale, so engineers and governance teams can refine rules, tune thresholds, and identify where automation should yield to human judgment. Balancing locality and scale is the craft here. Push what must be fast close to the inference path, and route richer checks into resilient, auditable services. Monitoring guardrails turns rule firings into actionable intelligence rather than a raw stream of alerts. Log enforcement actions with rich, structured metadata, the triggering input, the model version, the rule identifier, confidence scores, downstream effects suppressed, and the remediation taken. Measuring blocked outputs is more than counting rejections. Correlate blocks with user journeys and business impact so you can prioritize false positive reduction where friction harms adoption. Anomaly detection focused on bypass attempts is essential. A slow rise in near-miss scores, repeated evasion of a particular rule, or correlated spikes across regions can indicate a probe campaign rather than mere noise. Integrate these signals into a governance dashboard that surfaces trends, escalation needs, and forensic packages for each significant incident. Make retention and tamper evidence part of the design so legal and compliance teams can reconstruct decisions. Consistent, queryable logs transform what would otherwise be fragmented alerts into reproducible evidence for audits, post-incident reviews, and classifier retraining decisions. Measuring the effectiveness of guardrails is inherently a trade-off exercise that must merge technical metrics with user and business outcomes. Track false positive rates by rule and by user cohort to understand where rules block legitimate use. High false positives in critical flows demand human-in-the-loop remediation or relaxed thresholds. Quantify success in blocking malicious content with red team-derived benchmarks and live telemetry. How often did the guardrail prevent a harmful outcome versus merely flagging it? Measure coverage across your policy set. What fraction of documented governance rules are enforced automatically, which require review, and which lack technical representation? Crucially, report latency overhead introduced by guards and budget it into service-level objectives. Defenses that slow responses to the point of user abandonment will be bypassed in practice. Combine these measures into composite signals risk-adjusted friction scores that help leaders balance safety and usability and present deltas over time to demonstrate the impact of classifier improvements or policy changes. Designing guardrails forces you to wrestle with human-centered trade-offs where strictness and usability pull in opposite directions. Too rigid, and users work around the system, migrating to private channels or creating adversarial inputs that defeat detectors. Too permissive, and the organization risks harm and regulatory exposure. Attackers evolve. Prompt injection techniques, grammar-level obfuscations, and multimodal tricks require constant adaptation, and guardrails that rely on brittle signatures will age quickly. Multilingual enforcement complicates everything. Nuances, idioms, and script diversity mean that a rule effective in one language may be useless or harmful in another, so detection must combine language-specific models with universal policy scaffolds. Multimodal expansion raises further questions. Rules that check text may miss instructions hidden in images or audio, and harmonizing cross-modal policies without creating an explosion of false positives is challenging. The practical response is layered adaptation. Start with robust, explainable checks in high-value areas, use canary deployments and A/B testing to measure user impact, and invest in continuous red teaming and internationalization so guardrails stay current and credible. Strategically, guardrails are the mechanism that lets organizations scale model capability without compounding risk by making safe operation a default, not an afterthought. They protect brand and legal standing by preventing blatant policy violations from reaching customers and provide the audit trails regulators increasingly demand. Guardrails also enable product teams to experiment responsibly. With reliable safety nets in place, teams can iterate on features that use potent model capabilities while maintaining step-up approvals for actions that materialize risk. Moreover, guardrails are a communication tool to users. Visible behaviors labels, refusals, or safe fallbacks teach expectations and build trust over time. The strategic objective is not merely to avoid harm, but to institutionalize predictability. Stakeholders should be able to reason about what the system will do under stress, and the organization should be able to demonstrate consistent, measurable controls when external scrutiny arrives. Guardrail tooling matters because the right tools turn policy into practice at scale and make iteration tractable for design, operations, and governance teams. Open-source validation frameworks provide transparency and allow customizability for edge cases, while commercial safety APIs can accelerate baseline capabilities for classification, redaction, and format enforcement. Classifier libraries must be versioned, testable, and instrumented so you can measure drift and retrain with reproducible datasets. Policy management dashboards give non-technical stakeholders the ability to view rules, map them to governance requirements, and approve exceptions with traceable rationale. Integrations with CI/CD and model registries automate gate checks preventing promotion when guardrails are absent or failing, and exporters produce audit-ready evidence packages. Choose tooling that supports extensible rule formats, multilingual pipelines, and multimodal inputs because brittle vendor lock-in will hamper iterative improvements. Finally, treat the toolchain as part of your security boundary. Ensure defense in depth by pairing external APIs with internal verification and fallbacks, so availability, latency, and confidentiality remain under your control. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Choose your guardrail tooling with the same care you would choose a foundation for a building. It must be durable, auditable, and extensible. Open-source validation frameworks give you transparency and the ability to adapt rules to niche cases, while commercial safety APIs can accelerate baseline coverage where time to market matters. Both have roles in a layered stack. Classifier libraries should be versioned and testable so you can track drift and reproduce decisions. Policy management dashboards let non-technical stakeholders map rules to obligations and approve exceptions with traceable rationale. Integrate guardrails with CI/CD so promotion gates fail, builds when required checks are missing, and bind rule identifiers to model registry entries to show which policies applied to which version. Think of tooling as the policy execution plane. It turns governance prose into machine-enforceable checks, bundles evidence for audits, and gives you the agility to iterate rules as new bypass techniques appear. In practice, the right toolchain shifts guardrails from heroic interventions into routine engineering practice. Integration with governance is how guardrails stop being a purely technical project and become an auditable program. Each rule should map clearly back to a named policy, a regulatory clause, or a contractual term, so reviewers can answer, which requirement does this control meet, when auditors or customers ask. Reporting violations means more than logging. It includes structured incident packages that contain the triggering input, model version, rule identifier, confidence, and remediation steps so legal and compliance teams can weigh disclosure needs quickly. Link control health to compliance metrics, coverage percentages, time to fix, and exception counts, so governance reviews are informed by defensible evidence, not anecdotes. Document the rationale for thresholds and the human-in-the-loop escalation paths for borderline cases. These narratives help explain trade-offs and show reasoned judgment under pressure. When governance and tooling share a common language and artifacts, you convert opaque safety posture into verifiable, repeatable practice that regulators, customers, and boards can trust. Multi-tenant environments pose special design pressures because each tenant expects tailored policies, while the platform owner must retain consistency, efficiency, and auditability. Per-tenant enforcement lets you apply custom rule sets for regulated industries or VIP customers, but it requires strict isolation so one tenant's policies cannot leak into another's behavior or data. Segregation of rules should align with tenancy models, logical namespaces for policy definitions, separate evaluation contexts, and access controls that prevent cross-tenant inspection of enforcement logs. Centralized reporting then aggregates adherence metrics without exposing tenant data, feeding governance dashboards with summary indicators while preserving per-tenant detail for contractual review. Think in terms of templates. Offer a secure baseline policy that most tenants adopt, while allowing parameterized deviations that must pass review and be time-limited. This balance keeps the product scalable and defensible. Tenants get the customization they need, and you maintain a single pane of assurance for regulators and your board. Continuous improvement is the discipline that keeps guardrails current in the face of evolving adversaries and changing product needs. Treat monitoring not merely as a detection channel, but as a feedback loop that feeds retraining, rule refinement, and policy updates. When a near miss occurs, capture the interaction with full context and route it into a labeled dataset that helps retrain classifiers or adjust heuristics. When a false positive surfaces in a critical workflow, measure its business cost and tune thresholds, or add human review triage. Use canary rollouts and A/B tests to measure user impact before wide deployment, and schedule regular red team sessions that simulate new bypass tactics to stress your filters. Institutionalize post-incident retrospectives that translate findings into action items, classifier retraining, rule changes, UX updates, and documentation. So each event raises the floor of safety and the speed of recovery. Improvement is iterative. Small, measurable adjustments compound into robust defenses. Scaling guardrails requires engineering for distribution, elasticity, and graceful degradation so safety holds up under load and across regions. Implement guardrail services as cloud-native, horizontally scalable layers with stateless evaluation where possible and stateful caches for costly lookups. Use rate limiting and backpressure to prevent spikes from overwhelming semantic validators and design prioritized queues so critical policy checks retain low latency while lower-risk evaluations can trail into asynchronous review. Elastic resource allocation autoscaling workers for heavy semantic checks or batching for costly provenance lookups keeps costs proportional to demand. Deploy regional instances to reduce latency and comply with residency requirements, and use consistent configuration management to ensure rules propagate deterministically. Importantly, design fallback behaviors. When a deep semantic check is unavailable, the system should degrade to a conservative auditable mode, throttle, ask for confirmation, or queue for human review, rather than silently allowing risky outputs. Scalable guardrails are an architectural pattern, not a single product. Resilience testing proves that guardrails work when adversaries try their hardest to break them. It is the difference between theory and practiced reliability. Integrate adversarial bypass attempts into your test harnesses, prompt injection corpora, obfuscation grammars, cross-modal hidden instruction cases, and measure detection and containment rates under realistic load and latency constraints. Run periodic red team campaigns that blend automation and human creativity to unearth novel evasion strategies and exercise escalation playbooks. Measure defense success not only by detection accuracy but by operational questions. How long did triage take? How many users were impacted? And did recovery actions preserve evidence? Feed these results back into CI so failing scenarios become new unit tests for classifiers and policy engines. Finally, run chaos experiments that simulate partial failure semantic validators offline, degraded provenance systems, to ensure fallback behaviors keep users safe while preserving forensic trails. Testing resilience is the assurance that guardrails remain meaningful when they are needed most. Guardrails deliver strategic benefits that extend beyond immediate incident prevention into organizational assurance and market trust. They create a predictable safety envelope so product teams can ship more ambitious features with a known set of constraints, turning potential fear of unknown model behaviors into tractable engineering problems with measurable controls. For regulators and auditors, guardrails provide reproducible evidence logs of enforcement actions, versions of classifiers, and mapping from rules to policy that shortens reviews and reduces the cost of compliance. For customers and partners, visible refusals, labeled fallbacks, and consistent format guarantees build credibility. Users learn what to expect and can plan workflows around those expectations. Economically, guardrails reduce systemic risk. Fewer cascading mistakes, smaller remediation bills, and clearer vendor warranties. Culturally, they shift organizations from reactive firefighting to proactive governance, where safety is a design parameter rather than an emergency add-on. When designed well, guardrails are also adoption enablers rather than mere brakes on innovation. By codifying what is acceptable and what is not, they create safe channels for experimentation. Teams know which capabilities may be exposed directly to end users, which require human review, and which must remain internal until stronger evidence accumulates. This dialed exposure encourages iterative product development because each change carries a clear risk profile and an associated set of controls, rather than an existential decision. Guardrails can be parameterized per audience, stricter for regulated workflows, looser for exploratory research. So the same underlying platform supports diverse use cases without multiplying bespoke solutions. Over time, an ecosystem that favors interoperable guardrails encourages vendors to adopt common verification formats and policy mappings, easing procurement and cross-organizational integration, while raising the baseline of safety across the industry. Sustained effectiveness depends on feedback loops that convert monitoring into improvement, and that means integrating measurement, red teaming, and governance cycles into day-to-day operations. Track not only how often rules fire, but why. Correlate blocked outputs with user journeys. Classifier confidence with false positives across languages, and enforcement latency with user abandonment rates. Feed these signals into retraining pipelines and rule refinements so near misses become labeled data and policy drift is corrected before it leads to harm. Institutionalize periodic adversarial testing and cross-disciplinary retrospectives that make lessons, operational classifier retrains, UX changes, and policy updates become discrete backlog items with owners and deadlines. Governance should require evidence of these cycles, turning post-incident learning from an optional report into a measurable cadence that systematically raises the floor of safety. Operationalizing guardrails at scale is an engineering discipline that demands policy as code, CI integration, and observable evidence trails. Embed checks into promotion gates so a model cannot be promoted to production until required validators are present and passing. Bind rule identifiers to releases so audits can prove which policies applied to which model version at what time. In multi-tenant platforms, provide namespace separation and parameterized policy templates so tenants gain flexibility without undermining centralized oversight. Expose tenant-level metrics while preserving isolation and privacy. Choose tooling that favors exportable evidence and versioned classifiers so retraining and rollback are reproducible. Finally, automate deployment and rollback of guardrail configurations with feature flags and staged rollouts so policy changes are safe to test and quick to revert, making policy evolution as manageable as software evolution rather than an artisanal, error-prone endeavor. Design trade-offs will always exist, and part of guardrails engineering is learning to balance safety with usability, performance, and inclusivity. Overly strict filters erode user experience and drive workaround behavior. Lax guardrails expose organizations to legal and reputational harm. Multilingual enforcement and multimodal expansion exacerbate false positives and maintenance cost, requiring investment in localized models and diverse training corpora. Performance-sensitive paths demand creative architectures, fast syntactic checks in the hot path, asynchronous semantic validators in the background, and progressive disclosure patterns that preserve responsiveness while guaranteeing safety for critical actions. Accept that perfection is impossible. Instead, instrument outcomes carefully, prioritize protections where harm is highest, and document trade-offs transparently so stakeholders can evaluate residual risk and remediation plans with clarity. Guardrails engineering is a practical, repeatable discipline for converting policy into safe, observable product behavior, and it is essential infrastructure for trustworthy AI. You have seen how guardrails span input probing, context screening, output validation, policy mapping, tooling choices, and resilience testing, each layer contributing to a system that can be both capable and controllable. The next technical frontier is confidential computing techniques that protect data and models even during processing, where guardrails intersect with hardware-backed isolation and cryptographic protocols to further reduce exposure in shared or untrusted environments. As you prepare for that progression, keep the core lesson in mind. Safety is not a single control, but a composed, iterated architecture of people, process, and technology that you build deliberately, measure continuously, and evolve in response to real-world evidence. Thanks for tuning in to Bare Metal Cyber, your trusted source for cybersecurity educational materials, news, and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.